you need to inculcate that habit in you, in the way of thinking in you, that whenever you're creating or doing something with the resources in the cloud, ask yourself what is the cost it is going to be every time without fail, and you should know the answer. In that way, what you can also try out is things like this. So you can type Azure pricing calculator, okay, and then um, you can see they have created a pricing calculator. It can tell you approximately what price it is going to have if you want to do X and Y thing. For example, I want to create a virtual machine. I select this. Okay. It will add that head in the billing virtual machine section. If I want to create some other stuff, I can click on these tiles and it will create the heading in that below here. So now it has created virtual machine. Not created, meaning it has added a item that you can modify. So by default, it has considered this, yeah, a Windows OS at West US region, OS only, standard tier, okay, and things like that. And this is the configuration of the instance, 8 GB RAM, things like that. And it is going to cost me $100 $152. So you can change the currency from here to Indian rupee. So you can see that estimated monthly cost if you create such VM is going to be 11,000 rupees. Okay, at this rate. So 50 GB temporary storage, 8 GB RAM, two virtual CPUs. Now that is also considering that you are going to use this machine for 730 hours in a month. So you can reduce it. Let's say if I am using this machine only for 10 hours a day, that is 20, and not over the weekends, just for some testing purpose or something. And then therefore 20 days approximately and 200 hours. So I'm using this machine for 200 hours. If I do that, then it will change the estimate to a lesser amount automatically, as you can see here. So you can use this pricing tool calculator, and I'm sure other Google Cloud, sorry, cloud providers, other service providers will also have similar calculators, because cost is so important. So you can use this to estimate the cost. You don't have to do it yourself. All you need to know is what kind of things you can create, and you can play around with the different options and things like that. Okay. Um, so that is the costing part. Now let's come back to what we have covered so far. So we have covered in detail the entire architecture, right? So um, we we tried to use this architecture in terms of how an existing setup can be moved to the cloud, and entire architecture could be suitable for that. What is the at what level entire architecture operates? Is it IaaS solution or a PaaS solution or a SaaS solution? Can anyone answer that? Entire architecture.
IAS.
Right. It is an IaaS solution because ultimately what we are really creating inside of cloud are virtual machines and the required infrastructure for them, like virtual network, subnets, IP addresses, network security groups, right? And then we are deploying our own software, our own web servers, our own databases if required, our own application which will process the requests, um, web application, for example, right? So we also have to configure the application to listen to a particular port. The web server should listen to 80 for HTTP requests. Like that, everything we have to configure. So this architecture is IaaS based architecture. Now, rest of the architecture, the other four architectures that we have on this slide, they are not directly IaaS architecture, they are PaaS architectures, because we are, as you can see here, it is written purely PaaS solution. So it basically means is that as we move further down the line in this architecture, we are going to see more and more services getting employed to implement these architectures. Okay, but we have not studied those um, services yet. We were able to understand NTR architecture because we discussed about what is virtual machine and things like that. What is IaaS? What is virtual machine? What we need to do, and other than that, NTR architecture, rest of the things that you need to do for setting it up is basically your own setup in those virtual machines. So this ties up well. So we discussed it in the detail. Obviously, we also covered the additional what do you say, services or handy tools that are available to us, like API or application gateway, traffic manager, right? So all those were additional things that we learned about that. If we, let's say, we can discuss this WebQ worker architecture, and then I will tell what is the thing I am coming to. So what is a WebQ worker architecture? So WebQ worker architecture is a very simple yet very powerful architecture, and it is used, I think, in any web deployment worth some complexity. Okay, because of this key thing in between, the queue. Okay, and as you will know later, there is a lot of that goes in to enable a queue based workflows in cloud, because it is so useful. What happens in the WebQ worker architecture is that we have got a as we would imagine a web front end, right? This is on the client side, and rest are the blue boxes are on the server side. Okay, and obviously in between client and server, we have got the internet in that, right? So here this is internet. Okay, so we have got all these blue boxes, they are all part of these are all part of deployed on cloud. Okay, so the requests come inside, we need to authenticate the request. So there could be third party authentication, like you can use third party services, Google identification, Facebook identification. It could be active directory authentication, like if I log in. So what is active directory authentication? It is basically, we discussed a little bit earlier also. For example, if I log on to portal.azure.com, okay, and um, as you can see, I just entered my Monocept credentials, okay, and the authentication, I logged in into portal.azure.com, right? As you can see, this is now portal.azure.com. It is now getting authenticated from somewhere else, right? And it is using some OAuth version 2 authentication mechanism, and it kind of knows from where the authentication is coming, right? Request is coming, and some further down the line things. But when I provide my password, okay, so what is my password? One second. Sign in. So it is authenticating. Um, it is authenticating against the Active Directory that has been set up by Monocept inside Azure. Okay, it need not to be in Azure. It's basically a service available and deployed on Azure, because now Microsoft deploys on cloud, it could be deployed on this thing also, on-premises servers also, right? That was called Active Directory, and now that it is deployed on Azure, or it is an Azure service, so it is called Azure Active Directory. So it is having that information about me that such a person with this alias is part of Monocept, right? And when I logged in, it authenticated me against that and matched my password. It matched it, and then it's checked that okay, for this user, there is a MFA, multi-factor authentication enabled. So I need to still have a second authentication or second level of authentication, which is through the mobile phone, right? So all this process is happening not on the portal.azure.com. It is happening on a third-party authentication mechanism, right? So once I get the text and I can log in, it will come back to portal.com. For example, if I use Edge, which I use more often, it would already have that caching and it will automatically log me in. So you can see I have automatically logged in because the cookies and all are already there, and it has taken my consent to keep me logged in. But that is only a browser specific login. So I will come back to this once I complete this authentication, right? So that is what I mean by identity provider. This guy could be a different service. It could be a personal service like Gmail, Facebook, Twitter, or it could be enterprise identification authentication like just I showed you, Azure Active Directory, and equivalent in other services, Kerberos or some other authentications will be there. So that is a separate identity provider. Once I get that authentication through, then I get the request, right? So when I log in, before I could see this page, it first has to authenticate me. So that is why clearly it is a separate step. And before that step, you might not be able to get to what you want to serve back. So your request comes over here. Your request comes over here through the identity authentication. Then the web front end will take the request and send back the page that is getting displayed to me here like this, right? So authentication is a separate step, could be integrated within this solution, or it could be communicating to the third party like I just demoed to you. Okay. Once the authentication happens, the request comes to the web front end, and this web front end now could be virtual machines also, right? But like I said, in this WebQ worker architecture, what we are saying is that this web front end will be some service that can receive the requests. We will get into details of that during our discussions in this course, that what kind of services that is, but it is a service that can receive the requests, process them, and send back the requests back, responses back. So web frontend could actually talk to some remote service like payment gateways or some other data. It could directly talk to database if that is the case, or it could identify that the message that has come, it requires processing, and the programmer who created this architecture, he or she decided that we want to not keep web front end waiting. It will be put in a queue. So some of the requests which matches the requirement will be put in the queue, message queue. This is called message queue. So in terms of a message, the request that comes from here, from the client side, is a HTTP request, right? It is going to be a URL, as you all know now. HTTP colon myapp.com slash let's say purchase or order, right? And then this is the API. This is the web API. From this, parsing this will in the code will identify which function gets called of the controller function. Which controller function gets called? Okay, this is the handler of order API request. Okay, and question mark and some parameters. What is the item code? What are the quantity? What is the shipping address? That could be all part of this as a URL string, or it could be part of the body of the request. So if you study more for on web, this HTTP protocol, you would know that there will be a URL parameters in the URL, or the more detailed data, for example, uploading pictures, etc. They are part of the body. So it is up to the designer of the request that how this the information which is required at the backend is passed on as whether as a parameter on the URL or as the body, right? So once this request receives, this controller code gets executed and it creates a message object which will have some properties, and put that message object here. Okay, and then return the request that your request is under process or something, right? So like that, there will be there could be many messages in the queue, and queue, as you would know from data structure thing, is a FIFO thing, first in first out, right? So there are something called workers. What are workers? Where they see basically they are uh, code they are code or components which execute on a trigger. Execute on a trigger. What is that trigger? So what is that trigger? In this case, the trigger is that as the message arrives. Okay, so is there a message in the queue? If there is a message in the queue, the worker object will get created, meaning it will come to life. The code will get executed. What will that code do? It will read the first message or the top of the queue, read the message, process it, and delete the message, right? So processing is what it is the business logic. So for example, if you are order placing, so you place the order, put the data in the database, some update some tables to send the request back whenever information back whenever customer requests, or some connect with some remote service to manage the logistics and stuff. That is all business logic. But um, architecture wise, you have got this queue, and from that message you are executing this. Every time a message comes, this worker instance will get created. Now this might take little time, right? So more messages might come, so you will create more instances of the worker. So this is worker 1, worker 2 of, let's say if this class name is W, of worker instance, right? So they are worker instances. Like that, every time a message comes, it will execute the request by creating an instance of this worker object. Okay, this worker object, and process the request. So what do you think, what do you think the having a queue is the, what is the advantage of a queue in this case? So what is the why we wouldn't use a queue? What is it achieving in terms of gain? Because it is complicating, right, the architecture. We are the more components you have in the pieces you have in an architecture, the more complicated it becomes, right? So obviously we have introduced a queue, a worker, and we have to find out a trigger mechanism, things like that. So why will the queue, or how the queue helps? Can somebody guess it or think about it? Or in the right English, I think, How does the queue help? Hmm? Any guess? Any ideas? Anyone? How the queue will help? What it is achieving? We could have, what is the alternative, right? It is basically some processing has to be done. This is the processing that worker is doing, right? That processing, if done, will serve our purpose, right? So when the request comes over here, we create a message, right? Instead of that, what I do is when this the same request comes, instead of creating a message, I can copy this code and execute here as part of this web, as part of the code that gets executed on order API call. So this process, I can put the its code at the end of the day, right? I can put this here and then return the response back. So why have a queue when I can do it in the API call itself? Any ideas? No ideas? Anyone? Are you guys there?
Sir,
Don't
so
look.
that the page is always responsive when there is some heavy processing.
Yes, very good. So the idea behind is asynchronous organization execution is that responsiveness. We don't want our client to keep waiting for the request to finish. So we are offloading this processing part, which might be time consuming, okay, because it might take longer to execute or it might take longer to get the information from third party, things like that. So this piece is taking code time because of x and y reasons, because of which the client is having to wait. The page is hung, which is not a good user experience. So therefore we move this out to the background or backend, out of this controller code, the API handler code, into a separate process, right? So that way the client page will be responsive, and that user can do something else. Okay, but the question comes, sir, what will client do if this processing is still not complete? If I am waiting for my processing to complete, what will client do? Right, that is a genuine question. It might depend on the what do you say, scenario, right? In many cases, client could actually leave it in the background and do something else in the same web application. That is much better than having to stay staring at the screen without having to do being able to do anything, right? Even if, let's say, the payment is getting processed, or but payment is getting processed is a counter example, actually, because generally web applications, when we are doing the payments, they expect us to hold on to the screen, do not press back button or do not move from that screen to somewhere else, right? So that is the scenario where this cannot be avoided. You have to wait, right? But in many other scenarios, whenever you are putting a request, for example, um, adding the information to cart, right? That can be done in the background because you just clicked an add button and immediately started scrolling to some other item, right? But adding to cart, let's say, takes 3 seconds. So what if you have to wait for 3 seconds for it to add the item to cart? It will be frustrating for you, right? So similar like that, it could be, if there is something which is taking longer, it will be even more frustrating. So moving the item to cart could be moved out into a queue, and then and a backend processed, and when it is updated, you can update the information on the small cart icon on the top of the websites for cart items, right? But let the client continue. So there are scenarios, in fact, more common than not, where client needs to be always active. The client application work for the user, it should be always active and responsive, and that is one of the key goals of any web development, any application actually, to keep the interest and convenience of user in front and center in your application design. So uh, the primary reason why how the queue helps is it takes, or it is an async capability, right? It introduces async capability into system, okay, which basically keeps the application responsive. Or client app responsive. Okay, that is the key game. Okay, now there are other aspects like cache. Cache is one of the key components which is easily missed in many architectures. I gave you an example where I said there was a health application, a mobile application, which was getting very slow because these guys were not using cache. And that project I did basically and introduced a cache, and the execution of the whole process went much faster. Right? Caching is one thing which people forget, but the reason why people forget is it is a perf or performance related um, entity or a performance related artifact, right? Perf should always be secondary. Why? Because there is no point of having performance if the system is inaccurate, right? So first accuracy and then performance, right? So accuracy or correctness. So is your system correct? Yes. Then come to performance. Always. So don't, whenever you try to implement something, don't introduce cache in the beginning, but have it in the plan of your project that after, let's say, phase 3 of the project, where we are done with the deployment, we will implement this cache solution, right? Or in either ways, there could be ways where we could introduce in the beginning itself, but we should justify the cost always, right? Cost in terms of how much the cache will cost while running, and how much the implementation will get complicated when such introduction of cache happens. Do we really need it, right? Those are the questions that we need to answer. So before those, obviously the system has to work correctly. If your calculation is incorrect, what is the point of having cache, right? So performance wise, it won't matter if the answer is wrong. So our first focus should be correctness of the scenario. Whatever the user requires, does it work like that? If it works, how can we make it better? How we can make it better in terms of performance? That is when the cache comes. Okay. So in this WebQ worker architecture, the main key difference or key item is queue, because this introduces or separates the or decouples the client, decouples the API request handler and long or background process. So far, if you are using the long and background process inside of the API request only, because you did not know about the queue, now if you introduce queue, it will decouple that. It will decouple the request handler from the code that you could actually avoid in the request. Now you have got this could be put in the queue and then execute the worker request. Now there are, so let's go further than this. So this is the WebQ worker architecture in general. Okay, let's read about this so that we don't miss anything. So the core component of this architecture are the front end that serves the client requests, a worker that performs source intensive tasks. Source resource intensive tasks, meaning it could be taking a lot of network bandwidth, it could be taking a lot of CPU, it could be taking a lot of memory or even storage space, anything that is resource intensive. Or it could be a long running workflow, right, which will take a lot of time. Or it could be some batch jobs, a bunch of things that we need to do. So that is the worker is basically a program, a separate piece of code which will execute such things independent of the web front end, and a message queue. So the glue between the backend working thing, the workers, and the web front end is the message queue. The coordinator is the message queue. The web front end communicates with the worker through it, right? That is the glue. What are the other components that are commonly incorporated? So these are the core components. Without a message queue and something handling in the back end is no is the architecture is not web queue architecture. For example, you could introduce a queue, but if you add a message in the queue and add a function, uh, call a function, I'm just trying to construct it like this. So if you use a queue, that is fine. Add a message in the queue from one code, it comes over here. Call another function B, and inside of B function, you read the message and process it, all while you are in the front end, right? Even though you are using queue, it is not a web queue worker architecture. Why? Because you are missing the third this core piece of architecture, that there is no separate code which executes or processes the messages. So web front end will put the message in the queue. A worker or multiple workers will process the messages of the queue. It's not the same web front end should process the messages. That is the core component of this architecture. Okay. And then you could have database, you can have cache like we saw, CDN. So what is CDN? We will discuss about that, but CDN is called content delivery network. Okay. Some static content could be cached into different regions which could be closer to the client and then served from there, right? Some pictures or something. If I am in India and the web front end is deployed in the US, a lot of time will take to send the pictures around, right? So what they could do is they could deploy the common static content, which the pictures which are shown by to everybody in different regions. Like somebody could be a CDN network could be there in India, multiple regions could be there, multiple regions, small. It's like a data center, but it's very small, one server or something. Um, So it will be cached over there. So instead of the web front end sending the request, it will be served from the content delivery network, right? So that is it's also a kind of a caching mechanism, but only for static content, right? Static content is also large volume of data that goes through the network without having to change, right? That is static, but the volume is quite a bit, because most whenever whosoever logs in into a website sees the same thing, so a lot of static content will be there. Okay, so CDN to serve the static content. Then we have got remote services such as email or SMS service. Those could be the third-party services, these remote services. Okay, and identity provider for authentication that we also talked about. Okay, so Um, what is next? So that is the more points. So web and worker are both stateless. So does anybody know what is a stateful or a statelessness in software? Can anybody tell me? Have you studied about some software engineering design courses? What is a statefulness and statelessness? Object-oriented programming for. Can anyone tell me what is a stateless object? Have you studied a course on software engineering or software design? Anyone? So what is stateless? What do you mean by stateless when it comes to software or program? So statelessness means it does not carry any information or saves any information when a worker dies, right? Similarly, web. Every time you send the request, it will have its separate state. So that is what stateless basically means. Okay. Then session state can be stored in a distributed cache. The state of session can be separate, but not inside of the web and worker. It could be put in the cache, and that is a state which is the system state, not the individual web or worker state. They are stateless. Any long running work is done asynchronously by the worker, so that is obvious, right? They are not in sync with the web worker. So one more thing, for example, um, from this statelessness, the asynchronous thing, it came to my mind. So web front end, right? So you implement the web front end, put a message in the queue, worker gets created, okay, and before returning the request back to the client, you are waiting for worker to finish the job, update something in the database, okay, so that you can read it and send it back to the client. Okay, did you understand? So, sorry, did so you are what you were earlier doing? You are putting the message in the queue. So this message you created, put it in the queue, right? And then you simply continue the execution and return the response back immediately. That is what you were doing earlier, right? As per the design. So now what I am saying is, what about this kind of implementation? That I create a message, put it in the queue, and then I wait. Query the database, some data is updated or not, because I know what kind of thing will get updated. Wait, query it, wait, query it. In the meanwhile, if worker will get instantiated, processes the message, updates the database, okay, and once I query this, it is now got the response. I fill up the response object and send the query back, right? So this meets all um, conditions of web queue worker architecture. You've got a queue, you've got a worker, you've got a web front end, three core pieces, right? Processing of the message is being done, but it's a stupid implementation. Why? Because it is not achieving the true purpose of the web queue worker architecture, because it is still letting the client have to wait, because this is waiting, right? So there is no point of implementing this whole hangama if you just have to wait in the web front end itself for this whole processing to finish. So never do like this, okay? Okay, so it is done asynchronously is very important. That is the whole purpose of having this architecture, asynchronous, asynchronicity. So the worker can be triggered by messages on the queue or run on the schedule for batch processing. So, okay, so here is the some caveat. Worker is an optional component. If there is no long-running operations, the worker can be omitted. But who will execute the messages then? Okay, so I think I don't know. I don't know why this will be there. I have to check. Can you also check in your in online like why this would be an optional component? I think it should not be. It could be for the batch processing in the sense that you don't have a batch processing, but it could be that this queue might give you some processing power. That message queue, if you put message in some particular format, the queue itself will be able to execute. It could be that way, but for any serious message execution, you will need a worker. So I don't know why this line is there. I will also check. Okay. Anyways, coming back to the point where worker can be triggered, right? So the question when I was saying that the worker gets instantiated, this trigger mechanism when the worker code gets put in the memory for execution, how does who triggers it? Isn't it? Worker is a dead code, right? It is not executing right now. A message comes in the queue, right? So here, this is the state in the beginning, right? This worker, it unlike some web front end which is always listening to the front end, right? There is no such worker which is always waiting and running, consuming CPU cycles just for a message to arrive. It's not like that. Okay. Worker is a dead code. It is a dead or not executing every time, all the time. Okay. Only when a message arrives in the queue, this gets instantiated. Okay. Only when the message arrives in the queue, it gets instantiated. So it means somebody has to execute, somebody has to instantiate it, right? Who does it? So the queue, when the message comes in the queue, who will execute, who will create the instance that I was talking about? So I said this instance will get created, it will read the message, process it. This is the code, right? So code gets executed. So who is the person who does it? What is the entity that does it? That is the purpose of Azure service, some service in Azure or cloud provider. This guy will provide some mechanism because there has to be a third guy, right? Who knows that there must be a message in the queue and I need to instantiate this code to execute it. So there must be some watcher or some coordinator which will see the message getting in the queue, instantiate the worker, right? So this watcher or queue is job is done by some Azure service. So I'll talk about that. But it's not automatic. It's not magic. Somebody has to instantiate this worker code. Now, one of the watcher could be a schedule, meaning a time thing, as simple as that. Saying that we set up something in the when we created this worker in Azure, we set a schedule that run every 5 seconds. Okay. So what it simply does is what Azure does is you create a scheduler and give it a code to execute and put the what do you say schedule, and after that time it will execute that code, whatever that code does, right? Apparently, if we do that, whatever this code will do, it will just simply check if message in the queue, right? So then process, right? That's all it will do. So every 5 seconds, this code will execute. That is one way of doing uh, execution, but it is little costly, because costly in the sense it will execute anyways, whether there is a message in the queue or not, right? A better way would be set a trigger point. Somehow some watcher is watching the queue. As soon as the message comes in the queue, it will create the worker instance. That is more efficient, right? So those kind of watcher services are provided by cloud service providers, because that is where they bring their value. Okay, so there are um, triggering mechanisms for worker processes. Okay, the front end might consist of a web API. So instead of um, a web server which is serving web pages, it could be an API. So what is the difference between an API and a web server or web application? Not much. Web API could send a JSON in response or XML in response, need not to be HTML. Web server will send some HTML page. That is the only difference. On the client side, the web API can be consumed by a single page application that makes AJAX calls, or by a native client application. So API, it's a web API, right? It's anybody can call the API and process or use the response the way that application wants, right? So it could be a web page, so a single page application, and then it can make AJAX call, a JavaScript asynchronous calls, so that it can update the page without having to refresh it. Or it could be a mobile application or a desktop application, not a web browser page. An application which can call this API and use the information. Okay. Now, this is the architecture in general, right? How do you implement this architecture in Azure? Now that is where I wanted to come to, and move to other piece of our course, justifying that. Now, if you want to implement this WebQ worker on Azure, we need to be aware of a lot of services that are available. For example, there is something called web app, right? It looks apparent, but there are details about how to use web app, right? There is a service called service bus queue. There is a storage queue also. So service bus queue is a service for using this in this web queue architecture as a queue. Okay, workers, there are something called function apps. Okay, what are those function apps? How to create and how to do, which can be used as workers and tied up to the triggering mechanism that is provided by the queue. Okay, then we have a cache service called Redis, which has been acquired. Redis was an independent company or entity, and it has been acquired by Azure now. We can use that as a cache. We can use option of a SQL and NoSQL options in Azure. Cosmos DB is their NoSQL option. SQL database is their SQL option. Okay. Then for storage part, we can use Blob Storage. So these terms might be lot foreign to you, because we have not studied these. Now, that is why, to move further in the architecture, it will be prudent so if we want to, let's say, implement this WebQ worker architecture, right, we will be needing to create a worker. Now there is no worker as such in Azure. It is a function app, right? There we will have to create a queue, but there is no queue as such in Azure. It's a service bus queue or a storage queue. Two different services. Which one to use, right? Then Web front end. There is no web front end in the Azure. There is a web app application that is there in the service that is there in the Azure. So we will have to map the components that we saw in general architecture to the services that are there in the queue. Now, if we can probably quickly try it out, right? But that won't make much of a education, because unless we understand, let's say if we are using service bus queue, right? We know why we are using it, but there are many more details in the service bus queue, so we should know the details of it. Similarly, web app, similarly, NoSQL databases. Why, whether we should use NoSQL or SQL, how do you decide that, right? So that means we have come to a stage where to implement these architectures, we need to know more details on the kind of services that are provided by service providers, and what are their capabilities, where their advantages are, what kind of scenarios they should be used in. So all that detailed knowledge we need to know. Then only we will be able to use them and implement it in an architecture. Okay. So what we are going to now move to is that we will come back to these architectures after we gain that knowledge. Okay. Anti-error architecture, like we discussed, it was appropriate because uh, virtual machine was the only major thing that we needed to know, and we will be able to implement anti-error architecture in the cloud. But WebQ and onwards, we need to know other services of the Azure world. Okay. So that is why we will skip the architecture details and move to something else. So let me see, is there anything else? Okay, so this we will, because we have this WebQ architecture discussion going on, let us finish this and then we move to a next step, which I will just tell you. Okay, so but to complete the mapping, web application service, a web app, you will need to create a web app which is a PaaS service for receiving the requests in Azure, which will replace the web front end. Okay, web front end is implemented in Azure using web app. Queue, as I said, is implemented in Azure using a service bus queue. Okay, and function app is a service where you can write a code, like it says function, right? Function means some unit of code that executes in one go, right? That is in as a unit. So what you do is you write the code that you want to execute, create a function app in Azure, upload that code in that function app, and set a trigger mechanism of this function app. So that trigger mechanism could be a new message coming in the queue, right? That there are options in the function app. So new message coming in the queue can trigger this function, that app that you created. So every time a message comes, Azure will do it for you. It will execute that code. It will instantiate the function object and execute the code that you wrote. So that is what we wanted to do. So Azure is going to help that. It could be a time-based schedule. It could be directly, actually, function apps are so powerful. There is something called serverless computing now in the picture. So in function apps, there could be a trigger which is called HTTP trigger. So if it can respond to an HTTP request directly also, right? That is a serverless architecture. We will discuss about that. But coming back to the role of function app inside of WebQ worker architecture, it is by having this service gives you ability to execute the piece of code based on or tied to a trigger of the queue. Okay, so this function app then plays the role of an asynchronous worker component in the WebQ worker architecture. Okay, and this one is asynchronous, right? It is also efficient because it is based on the trigger mechanism. It is not scheduled. And the good news is the function app is cost. Like we have to think about cost, right? The function app costs us only when it runs, not when it is lying around like that. Web app instead will cost us continuously. Okay, web app will continuously cost us because it is always ready. Sorry, ready to listen. It is always ready to listen, so therefore it has to run continuously. If it is to run continuously, it is going to cost us continuously also, right? Function app, you deploy a function app, you create a function app, it is not going to cost anything just because you created a function app. Okay, you create a function app in Azure, upload your code in that, set the triggering mechanism. Till now, no cost, zero cost. Okay, a new message comes in the queue, the triggering mechanism we set was that when a message comes in the queue, execute the function app. And let's say it takes half a second to finish the work or execute that code that we uploaded, right? So as soon as the message comes in the queue, Azure automatically instantiates your function app. And the second thing it does is it starts the meter. Okay, starts the clock ticks, and the function app gets called, the code that we uploaded gets executed. It took 5.5 seconds, half second, and then finishes. So Azure will stop the tick at that time. So half second, next time message comes half second. After 2 minutes, a message comes half second. Like that, the Azure is going to um, charge only for those half seconds added together at a particular rate for us in the billing. Okay, so the main advantage of Azure function app is that it is executed only when on demand. It is not cost. It does not cost when it is lying around, right? So Azure does not charge you for keeping the code somewhere, for the mechanism um, that it has to keep looking at the queue to execute the function app. All those things obviously indirectly would have been covered by the charge that they do when it executes, but it still is much better than having a continuously running listener process here, which just keeps pinging the queue to get the message, to see if the message has come and execute if required. So quite an efficient service, and like I said, it's very interesting service. You should study about it. Very capable serverless applications can also be, created using a function apps. So you should, if you are interested, you should look about it. Then cache we have already discussed, NoSQL and SQL database. It could be either of the two or both of them. Okay, we will I will study we will study a lot about the NoSQL options in cloud. One reason being that it is so common for students to just simply use NoSQL. Okay, but I want to emphasize and I want to convince you that NoSQL is not always the right option. And second major issue is that we try to implement NoSQL databases like SQL database, which is completely wrong. And we will, as you will, we will come further and discuss. You will come to know about these things. So we will discuss about the NoSQL databases in general, and also the Cosmos database, which is a NoSQL service from Azure. And Blob Storage is again a like S3 bucket in Azure. simple storage service S3 in Azure, not in Azure, in AWS, and equivalent is this Blob Storage. What basically these are? They are services of large storage at very less price. So, but there are things that we need to be aware of and how to use them. What are the ways to use them? So that is why in each of these services, as you would have guessed, we need to go into the details and find out how they are used, right? Then only we can bring, for example, why can I replace a web app with a function app here, right? If I replace a function app, web app with a function app, set function app trigger as the HTTP request coming from here, it will work, right? So those kind of questions will come in your mind once you know the capability of these services. So once, um, fortunately, our because of our IQ in human brain, intelligent quotient, given sufficient knowledge pools, okay, two different knowledge pools, deeper enough, our brain is intelligent enough to bring the information from two knowledge pools, combine them together to bring something or to create a solution to some issue or to some problem, right? So that is why what I have also observed is if you know about some area in detail, right, automatically your brain will be able to, or you will feel that you have the capability to connect different things together to bring or to come out with a solution or come out with some uh, design or some information that is new or that solves the purpose or that addresses the problem that you are trying to solve. But the precondition to that is deep knowledge. The knowledge pool that you have, where you will pull the strings, okay, that needs to be deep. So it is important for you guys to deepen your knowledge in whichever area that you're studying, and in our course also same thing. But um, I I don't see enough attendance. 69 people, again, very less than 240 that have been registered. How many are registered? See, 246 students, and we are only 70 students in the class. And that too, I ask a question and you guys don't reply. Hardly anybody replies after 3 or 4 times asked. So it is an elective course, right? Elective course means you yourself are interested and want to learn from this course. But I don't see that enthusiasm. Um, Obviously, I will try my best. It is my job, but it will be helpful if you guys become a little more active. If you become a little more interactive, that will help. Any questions so far? Anything else? We'll end the lecture now. Otherwise, anything? Anyone? Okay. All right then. Take care, guys. Bye.